Hello viewers, welcome back to my channel. Hope you are doing great. If you haven't subscribed to my channel yet, please go ahead and subscribe. I have created several playlists for various problem categories such as dynamic programming, sorting, searching, BFS, DFS and so on. Please check them out. I have uploaded the code for this problem to GitHub. You can get the link from description below this video. Let's go ahead and jump into today's problem. The problem is first unique characters in a string. Given a string, find the first non-repeating character in it and return its index. If it doesn't exist, return -1. That means if it doesn't exist means all the characters in a given string are repeated, right? So we have to return the first non-repeating character, right? So let's see with an example, right? So Leetcode, in that L was never repeated, right? So we are looking only for the first unique character. So L is never repeated. So we give the index of the L, that is 0. So loveleetcode. So L is repeated in here. O is also repeated. V is never repeated. So the index of V is 2. So that's what we have to return. So another hint that is given here is the string contains only lowercase letters. So only lowercase letters in English, right? So there are 26 lowercase letters A to Z in English. So right. So basically we need to keep track of a given letter and see if it occurs again or not, right? So that's one thing. And once you keep track, you need to find out what is the first unique that occurred. So there are two things here. So first is we need to keep track of the character when it actually occurred more than once. If it is occurred more than once, then that is fine. But if there are characters which occurred only once, right? If there are more characters which occur more than once, right? So for example, in the Leetcode case, L occurred only once, T also occurred only once, C also occurred only once, O also occurred only once, D also occurred only once. But we are interested in the first unique character. So out of all L, T, C, O, D, L is the first character, right, in this string. So that's why we return 0 as the answer for this index. For example, if we are given with a string called A, B, B, C, C, right? So in that all characters occurred more than once. So we return -1, right? So for that, so Leetcode we return 0. For this thing like A, B, B, C, C, right, we return a -1. So that's what it is. So as we discussed, so English lowercase letters, there are 26 letters, right? So what we are going to do essentially here is we will do a placeholder class which will keep track of the start position at which the character occurred and end position at which that character reoccurred, right? So that's what we are going to keep track in the placeholder class. So we go through the entire string and fill up that list of those objects for the placeholder class. So we are going to put the placeholder class into a map corresponding to a given character, right? So since we know there are only 26 letters, the map will have 26 entries. So A to Z, right? So for A, when it occurred first, when it occurred last. For B, when it occurred first, when it occurred last. So likewise, right? So whenever we see the thing, right, when it occurred, that is when we are interested in, right? So map will have 26 entries. So once we maximum 26 entries, right? So for example, in this case, Leetcode, right, it won't have 26 entries for sure. So L, E, T, C, O, D. So it means it will have only 8 entries, right? So maximum the map can have is 26 entries, right? So once we have each of those characters starting and ending positions, right? So initialize the starting and ending position to the same. Basically L, for L we initialize the starting and ending position to 0. E we initialize starting and ending position to 1. Whenever we see the next time E, we update the ending position, right? So like that we are going to do the process. So once we go through this complete string and complete the map filling up, right, then we go through the map and find out if there is any character where the starting and ending position is same. So those are the characters which we want. When the character's starting and ending position is same, that means it occurred only once. If no character has the starting and ending position same in a given string, that means you have to return as -1 anyway, because all of them have more than one occurrence. So if there is only one occurrence, the starting and ending position will be same in our map, right? So, but what we are interested in is first unique character, right? First unique character. So what is the minimum starting and ending position is the question that we need to answer, right? So that is what our answer for this problem. So let's go ahead and try to apply that logic, right? So I have written the logic in a sentence formation here. Once we go through the entries and collect the starting and position of the location, keep track of the min index and initialize it to int max. So minimum index we initialize to int max basically. We go through the map and find out if the starting and ending location is same for a given character. So that means if it is same, that means it occurred only once, right? So if so, check start of the given character is less than the min index. So that's what we are checking. So if start is less than the min index, then we update the min index. Otherwise, we don't need to update. So min index is whatever it occurred. So finally, we return the min index. So let's go ahead and apply this logic to this first string Leetcode. So down below, I have put all the indices for L is 1, E is 1, sorry, L is 0, E is 1, next E is 2. So those are the indexes, right? So now I am preparing the map. So L will occur. This is the starting position, so this is a character and start and end position, right? So that's how it is. E, it occurred at 1 and occurred at 1. So when we go through the complete, so this is when we are going through the string, right? Going through the string and fill the map, right? So now, so when we are at second E, we update E to the ending position is 2, and next thing is T. T occurred at what? 3, right? So 3 is starting and 3 is ending, right? Right. So Leetcode, right? C. C is at 4, 4, right? O is also at 5, 5, right? D is at 6, 6, right? That's what we are initializing. And next thing, last thing is E. So E is already occurred. So we are going to update E as the last location is 7, right? So now we have this map, right? So we have this map. So now we go through this map and try to find out if there is a start location and end location is same. And let's initialize the min index to int max, right? So that's what we initialize, and we go through the map. So we are at L. L means this is 0. Start and end is same, and the 0 is less than int max, right? So we take the int max off and put 0 in there. And when we are processing E, the starting and ending are not same, so we ignore that. When we process T, starting and ending is same, so 3 is the starting location. So 3 is greater than min index, so we don't update min index. So C, next character, right? So 4 and 4, they are same. 4 is greater than 0. For O, 5 is greater than 0. For D, 6 is greater than 0. Finally, what is the min index we have left with? Min index is 0. So return this, right? Which is what we want, right? Return 0 for Leetcode. So this is how we are going to proceed. Let's go ahead and look at the code. The idea of the code is exactly the same what we discussed, right? So now we created a placeholder class, what I'm calling as place. So it will have start and end location, right? So I have a character. This is a map. For each character, I'm keeping track of the place that will keep track of the start and end location. So that will be in the map. I'm going through the length of the string. So I'm going through each character and updating the maps starting and ending locations, right? So with this, so once I update the maps ending and starting locations, I will have to go through the map, right? So initialize the min index to the int max value and go through the map. So while we go through the map, check if the starting and ending is same. In other words, I am checking the starting and ending difference is 0, right? If it is 0, that means their starting and ending location is same, right? So, and check whether the minimum index is minimum or start is minimum. So update the minimum index if it is minimum index is greater than start, right? So finally check if the minimum index is still pointing to int max value. So this means what? The string has all duplicates, right? All duplicates. There is no unique. There is no unique character. That means, right? So if that is the case, reassign min index to -1. Finally return the min index. So this is how the code is going to look like. So let's go ahead and look at the time complexity for this and space complexity also, right? So time complexity, we are going through the complete string s, right? So this is s. So the length of s. So let's say length of s is n, right? So that means for this for loop we are going through the entire string. So we will say order of n is the time complexity for this for loop, and the next for each. So this one is, so the map will have the maximum of 26 entries. So that means it is a constant number, right? So 26 is constant irrespective of your string length. Even if your string length is 100,000 or 200,000, it doesn't matter. The string length will change, but the map is constant because we are having only 26 English letters in lowercase, right? So this for loop will be executing only 26 times irrespective of the string length. So we can take that as constant, or plus order of 26 in that case, right? So it will be order of n plus 26. Since we don't care about the characters or the constants in the big O notation, finally the time complexity we are going to say is order of n. And the space complexity. So space complexity is, we are using this dictionary, right? As we said, the dictionary will hold 26 characters, right? So that is also a constant, right? 26 characters and 26 starting and 26 ending locations. So basically each entry in the map will have order of one character plus one integer plus one integer. So starting and ending. So that is order of 9 bytes, right? So, but of course this 9 bytes will change depending on the number of depending on the language. I'm just taking it in general, right? So this will be, we are multiplying it with 26, right? So 26 into that many, right? So 26 into 9 bytes, right? So this is all constant again. So what we are going to say is, it will be constant space irrespective of the string length. So the time complexity for this algorithm is order of n, and space complexity for this algorithm is order of 1. That means a constant. If you have any questions, please post them in the comment section below this video. I have posted this code to the GitHub repository. You can find the link in the description below this video. If you haven't subscribed to my channel, please go ahead and subscribe, and also share among your friends. Also, please click on the bell icon so that you will be notified about my future videos. Thank you for watching. I will be back with another problem very soon. Till then, stay safe and goodbye.